Section 4.1, Grandmaster, some critical thinking problems. Number 1. The formula d cubed equals 684t squared can be used to predict the relationship between the size of a storm and how long it will last. Let d be the diameter across in kilometers, and t be the time the storm lasts in hours. Part A asks us to rearrange the formula and solve for d explicitly, and then determine what is the diameter of a storm that lasts 2.3 hours. So first of all, what does it mean to solve for d explicitly? Well, we take this formula and we want to just write it as d equals something, not d cubed. So d to the power of 3 is equal to 684 times t squared. Okay. Well, how do you undo a cube? Well, that is to take the cube root. So if d cubed is this mess over here, that means d must be the cube root of this mess. So I put a little 3 here, and I write the root, and I make sure that everything fits underneath the 684 and the t squared. Right? So that is what d equals explicitly. And now we're asked to determine what diameter of a storm lasts 2.3 hours. So this number is t. So they're just giving us a specific value for t. So I'm going to replace t with 2.3. And then of course it's being squared. So with my calculator, I'm just going to work this number out and then take the cube root. Okay, so 684 times 2.3 squared equals 3618.36. Okay. Now, most scientific calculators, or a lot of them anyway, will have a cube root button. So if you can find that, which I have it here, you're going to get approximately 15.35. And this is a distance. It is in kilometers. There we go. If you do not, or have a cube root button, or you just can't find it, there's an alternative. What you can do is take this number and use your power button instead. You don't want to raise it to the power of 3. You want to undo that. So this is just an alternative for finding a cube root. And later on in this section, I'll explain why this works. But for now, just go with it. You raise it to the power of 1/3. Okay, so use your power button. Okay, and use the number 1 divided by 3 in brackets. Don't forget your brackets. Or you can just put in 1/3 if you happen to know how to use your fraction button. But please make sure you can actually get this number. If you cannot get this number, please come and talk to me, because I want to make sure that you know how to use your calculator. Part B. Rearrange the formula and solve for t explicitly. How long will a 5.6 kilometer storm last? So this is just basically the reverse of the previous question. Instead, we are given the size of a storm and we want to figure out how long it lasts. So let's see. Remember, it was d cubed equals 684 t squared. So to solve for t, I need to get rid of the 684. And I do so by dividing both sides by that. Okay, and that cancels. So that means t squared is d cubed divided by 684. So I'm close. But I want t. So how do you undo the square? Well, you just take the square root. So I'm not going to write equals, I'm just going to put an arrow. Okay. So therefore, t is the square root of everything. So make sure you make it big enough to hold everything, not just the top. There we go. So that is a formula for t explicitly. Now all we need to do is evaluate t and work it out when d is specifically 5.6. T is the square root of d cubed, but d is 5.6 cubed divided by 684. So what I'm going to do is I'm going to work out this on my calculator, and then I'm going to take the square root of my result. So 5.6 to the power of 3, and then I divide by 684. So I'm going to get an ugly decimal, and then I'm going to take the square root of that, and I get approximately 0.51, and this is in hours. Okay? If I multiplied this number by 60, I'd get the length in minutes. So it's just over 30 minutes. So it's about a half-hour long storm. A ball with a volume of 288 pi cubic inches fits perfectly inside a cubic box. Well, obviously, if it's a spherical ball, it has to be a cubic box. But what are the dimensions of the box? Meaning, what's the length, the width, and the height? Well, if I can determine the radius of the ball, I can easily figure out the dimensions of the box. Okay. I'm given the volume, and I think from that I can work backwards to determine the radius of the ball. Recall from a previous section that the volume of a sphere is simply 4/3 pi r cubed, or 4 pi r cubed divided by 3. Same thing. Only this time I'm actually given the volume, and the volume is actually given in its exact form. Notice how pi has not been evaluated. So I'm just going to replace v with 288 pi. So that is equal to my 4 pi r cubed over 3. So now all I need to do is isolate r. So I need to get rid of this 4 pi over 3. Well, first of all, I'm going to get rid of this division by 3 simply by multiplying both sides by 3. So that cancels there. Okay, so I'm not even going to work out this multiplication just yet. I'm just going to leave it. Maybe I'll work it out later. I don't know. It's still there. That's 4 pi r cubed. Now I'm going to get rid of this 4 times pi by dividing both sides by 4 pi. Okay. And of course, this all cancels here. But also, the pi's cancel out here. Okay. And that's because the answer, or the volume, was actually given to me with pi in it. So the radius cubed is 3 times 288 divided by 4. I'm going to work that out with my calculator right now. This gives me 216. Well, if the radius cubed is 216, that can only mean one thing, that the radius itself must be the cube root of 216. And, as it turns out, 216 is a perfect cube. We saw that from the previous video. Okay, that is 6. and there were units given, so the radius would be 6 inches, because remember that's a length. Okay? Well, we're not done the question. We've done most of the work, but remember the question wants the dimensions of the box. Well, we have figured out, come on, this is 6 inches. Okay, well, it fits perfectly inside the box. Therefore, the dimensions of the box, the length, the width, and the height, is actually equal to the diameter of the sphere, which is twice the radius. So that means this is 12 inches. That's 12 inches. So is this. Okay. So the dimensions are 12 by 12 by 12 inches. And there we go.